My name's William Morgan. I'm a director of the Linkerd project, which is a title I find a little bit funny, but we had to give me a title because I'm not a maintainer, but I still spend a lot of my time speaking about Linkerd. And so today I'm going to give you kind of the update on the open source project. I put a couple words up here. They're slightly different from I think what was on the schedule, but these are more representative of reality. We submitted the talk for this, many months ago. And if you saw my keynote video, I don't know if do they do that today or do they do that tomorrow? Not today. Okay. Well, when you see my 60-second keynote video, probably tomorrow during the project updates, I had to record that also, in April or something. And so it's like, well, I'll just give you my best guess as to what's going to be real by November, but I got pretty close. Okay, so without further ado, here we are. Thank you, true believers, for coming out. I'm going to do a quick ad before we get into the content. We actually have a whole bunch of Linkerd and Linkerd related talks here at KubeCon. Everything on the left side, which is grayed out to the point where you can barely read it, has already passed, so there's no point. Hopefully you made it to some of those. Tomorrow we've got a couple talks. This is the last kind of Linkerd related one today, but tomorrow we've got one about multi-zone clusters. That's semi-Linkerd related. We'll talk about topology-aware routing and kind of how Linkerd handles that and some of the pros and cons. We've got a tutorial about Gateway API, also semi-related. We've got kind of a basic introduction to TLS and mutual TLS. And then we've got another Gateway API talk. And then on Friday, if you're here Friday morning, you can come see me get yelled at as I, shake my fist in the air about open source and probably anger a lot of people. So that should make for a good time. So if you hate what I say today, definitely come on Friday. All right. Oh, and there's a QR code if you didn't see that, which links to a blog post, which has in turn links to schedule things. So I'll give you 3 seconds to snap that. 2, 1, done. All right, so here we are, Linkerd. How many of you have been to a Linkerd maintainer update, project update like this at KubeCon in the past? 3, 4 people? Okay, 5? Wonderful. So that means many of you are new to my particular brand of down-home, folksy humor that so many people seem to appreciate. That was supposed to be sarcastic. So Linkerd is a service mesh. I'm not going to spend too much time. I don't think I'm going to spend any time talking about what that means. Hopefully you at least know enough to navigate from there. We've been in production for 8 years at companies around the world. Big, healthy kind of community, lots of stars and contributors. We were the first service mesh to achieve graduation status back in, I don't remember when it was, 2021, I think. A whole set of logos. We haven't updated this logo slide for probably 4 or 5 years, so there's probably more. I think our job, so when people think about the service mesh, kind of a lot of people treat it as like a networking layer, or they treat it as, they start getting into proxies and things like that. To me, I like to take kind of a job-centric approach, and I think Linkerd's job fundamentally is to give platform engineers, right? So that's our audience. It's not the networking audience. It's not the network engineers. It's not really the security engineers, but it's to give the platform engineers the tools that they need to create a secure, reliable, and observable platform on top of Kubernetes. So if you are a platform engineer, or adjacent to one, then you are in our target audience. And if you're not, then we may be useful to you, but we're not kind of directly trying to solve your problems. And you'll notice I didn't really say anything other than we're trying to help you make a better platform. So I don't ultimately see this as a networking model or as a security tool. I see this as a platform tool. Okay, I've got 2 slides about kind of Linkerd versus everyone else. Sometimes I've been really aggressive with these slides, and I've yelled at other projects. In this case, I'm taking a moment to be mature. So what are the 2 things that I think distinguish Linkerd from other projects? The first is we try and keep it simple, and we have this whole set of design principles and this whole ethos that we follow. I've given a bunch of talks about this. I don't have, kind of the supporting slides if I really wanted to go into simplicity and talk about the Rich Hickey talk and all those things. But the idea is like, okay, we want to keep it this simple. Service mesh is notorious for being complicated, confusing kind of piece of technology to work with. So how do we not do that? How do we make it better? We've got a couple principles. I think actually I'd love to update this. I think we've got kind of like a more refined sense of this, and so I have a blog post in the works about what really are the design principles that have worked for us over the past 8+ years of fighting against complexity. But just work, right? So like that's a big one out of the box. We shouldn't require you to change your application to make Linkerd work. We shouldn't even require you to do any config, at least to get started, right? And then when you add kind of functionality and you need to involve config, that config should scale kind of sublinearly with the power that you're getting. Now, when we start talking about things like the gateway API, I don't know that we really stay true to that principle, but there are sacrifices and compromises we're making for reasons that I think are ultimately good for you. But this is the philosophy, even if we don't always live up to it in every instance. Don't be greedy. Let's no reason to consume more resources than we need to. Okay, that's good. Remove operational complexity, kind of similar to the simplicity theme. Can we make Linkerd something that when it's when it breaks and it's 3 in the morning and you have to like wake up and see what's going on, you can understand what's happening, you can have a mental model, you can debug the problems. It's not this, it shouldn't be this complex black box that you can never open up and that does some magic stuff. It should be something that you can understand as a human, even a 3 a.m. human. And then finally, security. We want to make it secure out of the box, so that should be the default. We shouldn't require you to do a bunch of work to make it secure. Okay, does this seem crazy so far? Anyone object to these philosophical principles upon which my entire career is based? No? Okay. No one. Does anyone want to take a stand for complexity? Did you raise your hand right there? No? Okay. All right. I got my eye on you. Okay, so that's kind of the philosophy side. On the kind of implementation side, the thing that makes us really unique is we don't use Envoy as a proxy. We build these things that we call micro proxies. Not my favorite term, but kind of it does 20% of what a full-fledged proxy does. So it didn't really seem fair to call it a proxy. We build them in Rust, so we get a bunch of nice security benefits. Security first, right? We avoid a whole class of memory safety vulnerabilities, which is really, really nice. Rust is super fast. That's awesome. We get access to this great network stack. So if you're into like asynchronous network programming, all the cool stuff seems to be happening in the world of Rust these days. But I think, if I tie this back to the previous slide, we want the proxy to be an implementation detail, not this operational burden. So we don't want you to think about the fact that there's a proxy there. It shouldn't be something that you're tuning and like worrying about as a separate entity, as much as possible. Obviously, there's always little exceptions, right? There's always weird services that are going to require a little effort. But by and large, it shouldn't be like a separate project. Okay, so that's like my introduction, my philosophical introduction to Linkerd. Let's talk about what has happened since Chicago, which was the last KubeCon, I'm pretty sure, the last KubeCon North America. So it's about a year ago. Okay, so we released, I think we released 2.9 releases of Linkerd since then. So I'll go through them one by one. We introduced Linkerd 2.15, which adds mesh expansion. And adds kind of in a limited way adds SPIFFE and Spire support. So mesh expansion means you can run the Linkerd micro proxy on VMs and on other on bare metal too. Anything outside of Kubernetes, as long as it's Linux. We don't have Windows in here yet. But so if you've got legacy kind of like Linux workloads and you don't want to jam them into Kubernetes, then we can at least mesh them for you and give you all the mutual TLS and rate limiting and retries and all the other features. Identity is bootstrapped through Spiffy and Spire. So in Kubernetes, we've kind of like always, I forgot I have this clicker. I'm really mobile now. In Kubernetes, in the cluster itself, we've avoided Spiffy and Spire because we have other ways to bootstrap identity. Kubernetes gives us a bunch of tools, so we didn't want to introduce anything else. Once you're outside of Kubernetes, well, now you're in the Wild West. Right now, it's like an arbitrary VM, running arbitrary code. So Spire and Spiffy actually turn out to be perfect. Like that's a problem that they solve. So that gives us the ability to have identity for these VMs, and we tie that into the mutual TLS certificates. We have this fancy new CRD that allows you to represent VMs, and some other niceties. So the theme of this was basically moving beyond Kubernetes or extending beyond Kubernetes. The control plane still has to run in Kubernetes, right? And I think that's always going to be the case for Linkerd. We've got too many kind of assumptions baked in and too many bits of Kubernetes that we rely on. In fact, that's like an explicit choice for us to really ever have the control plane outside of Kubernetes. But the data plane can extend beyond it. Make sense so far? All right, 2.16 came later, and if I were being frank and transparent, I would say this was kind of like a cleanup release. Of course, I like to talk about the extra features and stuff. IPv6 we added here. We added a cool mode for policy. If you use authorization policies, we've got this whole very complex and, oh, no, not complex. Well, it kind of is because it's based on the Gateway API, but we've got this whole powerful and sophisticated system, I guess, for doing authorization policies, which basically means if I'm service A and I want to talk to service B, like, is that allowed, right? Normally, Linkerd will do everything possible to make that happen, but you can put in policies that say, no, that's not allowed. Or you can say A is only allowed to talk to this one gRPC method on B or this one HTTP route, things like that. So, you turn those policies on and things might break. So we added an audit mode. But really the majority effort that went into here was kind of redoing our retries and timeouts logic to be, and also metrics, including per route metrics, to be on the native Gateway API types. So how many people are using, I should have asked this at the beginning, how many people here are using Linkerd today? Healthy number. Okay. How many of you are using service profiles? None of you. Wow. Okay. Well, great. In that case, we're just going to deprecate them. That'll save us some time and energy. No, we're not. So, as part of this, we decided we're not going to deprecate the service profiles. Were kind of the first, one of the first CRDs that we introduced, and we tried to be very judicious in introducing CRDs. And that allowed us to do per route metrics and things like that. Now that we have the Gateway API, we're kind of like moving more of our config surface area over to that. But we're going to keep supporting service profiles basically for eternity, I think, at this point. And so we have, the point of all this is we did a lot of work for 2.16, but really the majority of that was this kind of like cleanup thing to get parity between the features we had supported with service profiles and the features that we now support with the Gateway API. Is there anyone here who would like me to explain what the Gateway API is? Okay, one. Is anyone who would like me to not explain it so they can stay pure? Okay, well that's 2 versus 2 here, so we may need a tiebreaker. All right, I'll spend 30 seconds narrating. Is there anyone here from the Gateway API project? All right, I've got perfect freedom. Now we're not recording this, right? So the Gateway API, so you start out in the olden days, we had ingress, right, as a resource in Kubernetes. And ingress was like supposed to represent, how we configure traffic coming in the cluster. Of course, the problem with ingress was that it was a very minimalist type and it couldn't express all the many, many things that we wanted to express. So pretty much every ingress controller had its own set of CRDs. Okay, that's not great. So let's build the API that can allow us to, to actually capture that, so we have a Kubernetes native API that can support the wide range of ingress functionality. Okay, so we do that and we call it the gateway API. Now it turns out that the best way to do that is to have a whole bunch of CRDs and to have them kind of relate to each other. And so you end up with, a CRD that represents this thing, and it references another CRD that represents this thing, and it references another CRD that represents this. And so you end up with like these series of resources. And you can imagine, each of these is like, a row in a database table, basically, and you're like doing joins across them. So very sophisticated, very powerful. It actually did accomplish its goal, and it was pretty well designed, and so we started using that because we also needed, in Linkerd, way back in Linkerd 2.12, we were like, we need a configuration to represent like a slice of traffic. How do we refer to a whole set of, how do we refer to just the HTTP requests that are to this route and that have, this source or something, right? That's a kind of a thorny configuration, like design challenge to solve. Well, it turns out the Gateway API had already solved it. Okay, great. So we started using that, and then other people realized, hey, a lot of what's happening with the Gateway API, which was designed originally to solve ingress problems, actually makes sense for mesh. And then there's this whole working group called Gamma in all caps, which was basically, how do we, and it's still going on, I think, how do we adjust the Gateway API? How do we tune it so that it can represent not just ingress cases, but also mesh use cases? So the past couple of releases, we've been kind of heavily moving more and more Linkerd functionality, especially the new stuff, to be represented by the Gateway API. Now that's good and it's bad. It's good in that those types are already on your clusters. So, unless you're running an ancient Kubernetes version, you have Gateway API types, so we're not inventing anything new, and that's great because I don't want to be on the hook for inventing those types. Now it's bad in that we're kind of, I think we're kind of exhibiting we're at the very boundaries of what a human being can plausibly create and understand in terms of like YAML blobs that reference each other. Because as soon as you start going down this path and you do things the right way with the Gateway API, you end up with like a whole bunch of CRDs and they all talk about each other, and if you get the thing wrong, then like they just silently fail, and it just gets, more complicated. So I think it's great, and that's kind of why we're doing it, and I think it's kind of the future. Right now, my personal opinion is that we're kind of in this like painful state where we're asking you, and anyone who's relying on the Gateway API, we're asking you to create these types which are rich and powerful and expressive, but are also kind of hard to use at scale. So there we go. That's my explanation of the Gateway API. I don't think there's an escape for anyone at this point. The doors have been shut, so we're going to have to figure out how to live with it. Okay, so that brings me to Linkerd 2.17. So 2.16 and 2.15 are actually out today. 2.17, there's an edge release out as of like last week that basically has this functionality. We haven't gotten the docs polished. We have a little more testing to do, so we're probably like 2 weeks out from having an official 2.17 announcement. But the features in here are super, super cool. So we spent 2.16 kind of like doing some cleanup and fixing some windows, some broken windows. Now with 2.17, we actually get to, flex our feature muscles a bit. Do I only have 10 minutes remaining? Boy, I'm really dragging this out. Okay, so let me keep going, because this is a fun part. I shouldn't have wasted all that time on those other old releases. Egress metrics, egress controls, that's traffic leaving your cluster. I've got a slide about each of these. Rate limiting, super cool. Federated services is probably my favorite feature in this. Okay, so let's talk about egress. So traffic leaves your cluster. Turns out lots of traffic probably leaves your cluster. You don't necessarily know what it is. So the very first thing we want to do is give you the ability to capture and get metrics for all the traffic that's leaving your cluster. So how do you do that? This little YAML block on the left is the equivalent of a YAML hello world, I guess. It's like, only 8 lines or whatever, 12 lines, that basically says, hey, Linkerd, I actually want you to capture metrics for all traffic leaving the cluster. Okay. That's pretty straightforward. Now, if you want us to look at the TLS, sniff the TLS SNI header, and actually track metrics through by host name for your TLS traffic, well, then you have to do this more complicated thing over here on the right that says, oh, and by the way, if you see traffic that's going to 443, then let's treat that as a TLS route and do metrics based on the host name. So what's cool about this is that it does not require any changes from any of your applications. You can drop this in today with that edge release, and you'll start getting metrics, and you will be shocked and horrified by all the traffic that's leaving your cluster, probably. Okay, but that's not all. So once you can measure it, of course, you want to control it. What is the point of being on the platform team if you can't control what other people are doing? Like, finally, we've been powerless all our lives, and now we have a taste of real power. So let's use that power to control egress traffic. So if you want to disallow all traffic leaving the cluster, just clamp it down. Okay, that's that thing on the left. You can kind of do that with, I think you can do that with CNI, like network policies, I think. But now we want to allow traffic, and we want to allow it to not a CIDR or a set of IP addresses or a port. Well, I guess it is a port, but we want to allow it to a host name. And so that block of YAML on the right, which I forgot to colorify, so you'll just have to do that by yourself. You can see there's an HTTP bin there underneath the host names section there. And for those of you who are astute in the ways of Gateway API, you'll notice that these TLS routes are actually Gateway API objects. So this thing on the left, the egress network, that's Linkerd specific. The thing on the right is Gateway API. All right, does that make sense so far? All right, rate limiting. This is, if you're familiar with what this looks like in Istio, this is like about 1/1000th of the size here. So rate limiting, is basically, hey, I've got a fragile service, or I've got a service where I just don't want too much traffic hitting it. Here's what it looks like. Limit it to 1,000 or 100 requests per second in this case. Now, this, we introduced circuit breaking a couple of releases ago. Circuit breaking is a client-side feature. So circuit breaking says, if I, as a client, am talking to a server that's returning a lot of errors, then just cut it out, stop talking to it. This rate limiting is a server-side feature. If a client is talking to me and it's talking too much, then cut it out. I have here what I've done, this config is for a global rate limit. We also have per client rate limits, and so you can start doing kind of QoS games. And it's pretty cool. Okay, now federated services. This is the one that I'm most excited about because this is where we get to advance, I think, the state of the art a little bit. My example here is not quite as pretty, but if you imagine you have a cluster called West, North, East, three clusters, you do the standard kind of multi-cluster linking between those three. We can actually take that, we can now take that a step further, and we can say, hey, I want you to treat every service on there with this name as kind of one union service. And then from the client perspective, if I'm sitting on the client on the West cluster in this case, and I talk to a service called BB-Federated, so the services are called BB, and it's the same service on each cluster. If I talk to the service called BB-Federated, well, now I'm actually going to load balance across all endpoints on all those clusters, including my own cluster, which means all of Linkerd's latency-based load balancing can help me pick the fastest endpoint. If a cluster dies, or if the service dies on the cluster, or if the service half dies on the cluster, the load balancing just sorts it out. So suddenly I have this really nice primitive for operating on clusters or on services that are replicated across clusters. Now, there's still some refinement we can do here. I'm sure the first thing you're asking is well, it's called BB-Federated. It sounds terrible. You can use HTTP routes. You can use the Gateway API to make an alias service and make that a better name. And there's some config and stuff that we're introducing. But this is really exciting for me because I think what we're seeing is kind of a change in the way that people do multi-cluster, and that's one of the things to make it easier. We've got more fun stuff like that coming on the roadmap. All right, the other thing I announced is Linkerd is a sustainable project. This is a controversial one because I have to talk about the evil corporate backer of Linkerd, but Linkerd is developed, I decided I'm just going to be really upfront about it. Linkerd is developed primarily by one company. That company is now profitable, and more importantly, it's profitable by selling Linkerd, basically. So that's really, really good for Linkerd. It means Linkerd has a future, has a long and glorious future. We've used that to add new maintainers, increase velocity of output, all that stuff. So lots more to say. This is what I'm going to be, getting yelled at in the open source 2.0 panel on Friday. But I think it's really positive for Linkerd as a whole. Okay, and then I have a quick, how am I doing for time? I have a very quick housekeeping note, and then I want to get to questions. So this is a model that we're following, and we've updated the docs to kind of like reflect this, but I just want to talk it through. So we are still releasing versions, right? We're talking about Linkerd 2.16, 2.17, 2.18, right? Those versions represent a bundle of features, and they represent a bunch of docs, right? And that model still works for us. It helps with development, helps focus our efforts. We also publish edge releases. Every edge release, unfortunately, has its kind of its own naming scheme, which is like a chronological one. So 24.11.13. Oh, I don't know why I put 13 in there. It would be like the 13th edge release in November. That'd be pretty rare, since we usually do one a week. So edge releases have all the latest code. They've got the bug fixes, security patches. If you look at the release notes and you look at the the Linkerd, just on the GitHub kind of release notes, we actually mark those releases as recommended or not recommended after they've been kind of, floating in the community for a week or two. So if you stay behind edge releases by like 2 or 3 weeks, you get a pretty solid product. And then when we talk about a specific version like 2.17, we actually will do, we'll say, oh, if that corresponds to this edge release, and we'll tag Git. So if you want to get Linkerd 2.17, you know exactly where to get it. Okay. Oh gosh, I forgot about this. I got a roadmap. All right, I'll run through this. TLS origination, that'd be super fun. These are like all things we're kind of planning on working on in some capacity. Unordered lists, so please tell me what you want. Ingress, it's going to be really exciting, and I can't wait to ship an Ingress product. Windows support, definitely interesting for us. Mesh expansion for private networks. Right now, we only support it for kind of gateway. For pod-to-pod networks, flat networks. Further multi-cluster improvements. There's so much more to do there. If you're familiar with the link object in Linkerd, that thing works when you have 2 clusters. It starts getting really hairy when you have like 50 clusters you're trying to all link together. Spiffy inside the cluster. That's a lot of people have been asking for that, for better or for worse. More configuration on federated services. Okay, we're all here in the CNCF project pavilion, so come, you can, if you want to yell at me in person or other maintainers, I'm right there. And then we have like, I don't know, 2 minutes for questions. All right, what? I've got 7 minutes for questions? I've been rushing this whole time. I don't want to do 7 minutes. Let's sit in silence for like 4 minutes, and then we'll have three for questions. All right, let's do questions. I saw one hand over there. If you shout it out, I'll repeat it, or you could brazenly step up to the mic.
So my question is it working?
Yeah.
Okay, so the Egress network was an interesting CR. Is it a VRF-aware configuration?
Your question, was it a what configuration, the Egress?
The Egress network.
This thing where it says kind Egress network?
Yes.
Yeah, so that is a Linkerd like CRD that we've introduced that represents, I don't know, Egress network, I guess.
Yeah, but I mean, usually what we do, we have multiple Egress networks per VRF. So is that can block or control all those networks?
Ah, I see. So like, what's the scope of this
Yes.
thing? So I think the way it works is we kind of did a little hack thing. Well, maybe it's not a hack. I don't know. But if you set the namespace as Linkerd-egress, then it applies cluster wide. But if you want to apply just to a namespace or just to a smaller scope, then you can use it. Put a specific namespace in there, and then you could have multiple egress kind of networks. This represents it's like policy really over egress network more than anything else.
Just last question regarding same resource. Is it just for the primary network or can be applied even for multis?
Oh, okay. So this is like you've got literally multiple.
Networks.
Yeah. Great question. I don't know the answer. Excellent question. But if you come find me at the maintainer thing, we'll find someone who knows the answer. All right. Let's do left side of the room.
So you mentioned about the service profiles, and I did say we're using Linkerd, but we're getting into it. And so since we're kind of getting into it, should we not worry about service profiles and just go all in on the gateway API implementation?
Yeah, great question. So I would start, if you're just getting into it today, I would just go straight to Gateway API and just bite the bullet on that. Service profiles will be around forever, but like most of the new juicy features are really going to be Gateway API centric.
And then just a small other question. You said the metrics, are those exposed by Linkerd and capturable by Prometheus, or are they another?
Yeah,
Okay,
no, that's exactly right. They're exposed the same way all the other Linkerd metrics are on a /metrics endpoint. It's in prom format. They can be scraped by Prometheus and Grafana and then take it from there.
Cool. Thank you.
Yeah, great question. All right, yes.
Hello. Really good talk, by the way.
Thank you.
Great comedy. I was interested, you mentioned something about policy audit.
Yes.
At one point. So there's kind of two things. One, is that related to Gateway API policy attachments?
I don't believe so.
Okay. Then I'm actually just curious.
80% confidence on that answer.
Yeah. I'm just curious as to what it is, if you could go a small bit more depth into what that policy audit is.
Yeah, so basically it's just it's a binary mode where you say, hey, for this authorization policy object, rather than enforcing it, so like if something violates a policy, you got to, A talks to B and it's not allowed to by the policy. Instead of enforcing it, allow it anyways, but log a message and like update a metric somewhere so that you have a policy that you've put in place that is being violated before you flip that thing on and potentially disrupt production traffic.
Okay. And is this
It's like a dry run.
Yeah. And is this something specific to Linkerd's policy? I see it on the screen there, like your policy.linkerd.
Yes, it's in, there's like an authorization policy CRD that is specific to Linkerd that then like talks to all these gateway API types or references them, and I believe that's the level at which you set the audit mode. Yeah.
Cool. Thank you very much.
All right, you're welcome. All right, over here. Uh-oh, he's got a smile. Oh, yeah. He's got an evil smirk.
It's a tough one.
Oh boy.
So mutual TLS, right?
Okay.
Let's say we have a bunch of internal services that are all communicating over OIDC and mutual TLS. Is that something we can use with, Linkerd and be able to expand on it so we don't have to like release all these tokens and deploy them through Helm charts to all those individual services?
You have a bunch of services that are
interconnected, talking to an OIDC provider like Keycloak or something like that. And sometimes with some services you see annotations that you can apply, and then you're sticking your tokens in annotations, and that's poo-poo.
Yeah. So Linkerd's mutual TLS is very selfish, and it really only works when a Linkerd proxy talks to another Linkerd proxy. It doesn't share its TLS keys. It doesn't try and like be an externally usable TLS. It's very, very selfish.
We can't wrap a service with it or anything like that.
You can wrap it for like internal, so other meshed services could talk to it, but you couldn't wrap it for like external access.
Well, all internal inside the cluster, right? But
if these things were all speaking over TCP communication, then you could wrap it all in mutual TLS. Yeah, you just, you wouldn't be using anything other than Linkerd's own TLS certificates that it makes its own special way and doesn't share with anyone else.
All right. Okay. So not exactly what I'm looking for.
Right.
Thank you.
Yeah.
Thank you.
Yeah. No worries. All right. We've got 30 seconds remaining for one last question. This is going to be the most profound, astonishing question of the night. Ladies and gentlemen.
You put on there a bullet about ingress. Can you elaborate on that one is?
Yeah, ingress. Okay. I got 20 seconds to answer. I would like to take Linkerd's functionality and extend it to how do we handle traffic coming in to the cluster. That's really all that means. We're at the point now where like, I think we're ready. We've been ready for a while. We've got the gateway API as kind of like the thing that is describing the future of ingress. So like, let's just plug those two things together. There's a lot more to it than that is like my perspective. But yeah, that's what that means. Throw away your old ingress controllers. Linkerd is here. Yeah, replace those old, worn out ingress controllers with beautiful new Linkerd at some point in the future.